Okay, good afternoon, everyone, and thanks for coming along this afternoon. I have to say, I've got a bit of a tickly cough, so I've got my water here. So hopefully I'll make it through. I'll soldier on. So start with some introductions. I'm Rob Charlton. I'm Chief Exec of Space Group. And Twinview is part of Space Group, and Space Group Twinview are sponsoring this this webinar. I'm an architect by profession, and you might ask, what does an architect know about operating buildings? And over recent years, an increasing amount has become a particular area of interest for me. So I've done a lot of research, a lot of reading around it, and I've been doing some preparation over the last couple of months for this presentation. And certainly found it an interesting subject, talking about getting my head into productivity. So just to give a little bit of background to Space Group, because it is relevant to how we go from a design of a building right the way through to operation, and that process is the story of Space Group. We've been around 65 years, and at the top there you'll see the word space. That is the space architects practice that started out 65 years ago. And then about 20 years ago, we realized there was a real opportunity using digital. And cut a long story short, after a few years, we saw an opportunity for a digital consultancy, which is BIM Technologies, and that helps clients maximize the opportunities from their design and construction and operational process, and gives strategic advice. Still going strong today. Mainly works in London, but on other projects around the world, giving clients that technical advice. And then around a similar time, about 2010, 2011, we identified there was a need for data, information, accurate components for these new models that we're developing. So we developed BIM Store, which would give access to specifiers to 3D information, and would connect manufacturers and specifiers. So it stayed like that for the next 5 to 7 years. But the clients that we are working with around BIM Technologies in particular identified a need for using these models that they were investing in. And that's where the story of Twinview started, where it started out as a viewer, then an FM tool. And then in the last few years has become a full digital twin, which encompasses all of the operational data to optimize buildings, and puts all of that information into a single location. So that's the story. So you can see it's extended the whole life cycle over 65 years. So today's discussion in particular is around the increasing productivity, particularly around buildings, and with a specific focus on the commercial real estate sector. But obviously the same principles apply to many other of the sectors. It's an interesting time for all of these discussions, because every business is going through a period of adjustment and assessment. Now we're through the other end of the pandemic. We're all looking at the spaces we work in. We're seeing how it's used. We're seeing how people do work. So some people are working from home. That there's in some areas significant underutilization of space. So it's a real time for rethinking and looking at the assets that we've got and how we work. So a similar thing to start with is just, I took a look at where the UK, and I know there's people from all over the world on the call, but I was specifically looking at the UK and how the UK performs in a global level in relation to productivity. You can see there from the graph, it doesn't make good reading, and the growth per worker in the UK has continued to decline since the financial crisis of 2007, 2008, and the output hasn't increased either. And actually, in between 18 and 19, it did decrease. And then in the overall league tables, the UK is 31st out of 35 OECD countries. So certainly from someone based in the UK, it doesn't make good reading. And in my research, trying to unpick the reasons for that is quite a challenge, and there are many, as you can imagine. But certainly there are areas where being involved in the built environment, that's some impact that we can make. Obviously, other productivity is linked to manufacturing and things like that. So then the next thing is looking at what actually is productivity, and having a look at what that means. Productivity is the effective and efficient use of resources in a business organization. I quite like that as a very simple definition. And then picking out the three main areas of all of the elements that we have in around buildings and work. So around time, people, talent, and knowledge. And then we have information, systems, finance, energy, land, buildings, equipment, space, materials. All of those things impact on productivity. Sometimes they're separate, sometimes they're together. But actually what we'll come about and talk about today is actually we don't know a great deal about those three main areas. And then so some interesting definitions again here. So being effective is doing the right things, but being efficient is doing the right things right. And then I quite like the definition at the bottom where it said productivity is the amount of value produced divided by the amount of cost or time required to do so. So it's really starting to understand what productivity means and how we start to define it and understand it. And I think certainly many companies or building owners haven't necessarily got into that level of detail in the past. And then just taking a step back, I remember sort of 70s and 80s hearing the term time and motion studies, and it was parents and grandparents talked about it, and it was government departments where there was people coming in and seeing how people were performing and what they could do to improve it. And the time and motion is the scientific study of human resources and search for an efficient way of doing a task. And its development goes right back to the 1880s, a guy called Frederick Taylor, and he started with the time study. Then sort of 40s and 50s, there was a couple, Frank and Lillian Galbraith, who developed the motion study. So this whole idea of understanding how people work, operate, has been around for many years. I think what's different now is there is a potential of digitizing that, because in the past, I can just imagine the people with clipboards and interviewing people and trying to find out what people are doing going back many years. So it's got a long history, productivity. And then the other thing that struck me was when we look at many other things in our business, so return on investment, and anybody that's in the marketing field will hear that term all of the time, demonstrate return on investment. And we have incredible statistics that we can get now about basically aligning every penny that you spend right the way through to how that becomes as an inbound lead, for example. So we do a lot of analytics about that. But actually, when you start looking at other parts of your business in relation to your cost, and people is 50% of your cost, how much do we understand about that, and how much do we understand about the return on investment in that? And I think that's one of the things that business needs to look at, is understand where it's using its resources and how it can improve that. And obviously, one of the areas that we've been looking at is how a digital twin might be able to support improvements in productivity. So the starting point, as you imagine, is what is a digital twin? Because there are many different definitions. And to be honest, from our point of view, we always say this, really the definition isn't that important to us. Even the term digital twin isn't that important to us. What we're interested in is improving outcomes. And however we do that is what we're interested in. But if you do want a definition, we quite like this one. So a digital twin is a virtual representation that serves as a real-time digital counterpart of a physical object or process. So what that's saying is, in very simple terms, it's a digital version of the physical. And just sort of hot off the press, earlier this week, there was an article from the BBC about digital twins. So it's clearly becoming mainstream. And I think when you align it with what's happening with the metaverse, if anybody understands that, but certainly what we're moving towards a digital environment, and I think digital twins will play a part in that. And this article very much reinforces that and talks about digital twins right from human digital twins right the way through to building digital twins, aircraft, and all those different kind of things. So it is increasing all of the time. Just some examples which are used when anyone's talking about digital twins, but obviously has been used in the aviation sector around jet engines for many, many years, where there are thousands of sensors on a jet engine, which is monitoring how it's performing as it moves around the world. And then probably one that's more familiar with people is in the Formula One world, where these cars are moving computers and are connected to hundreds of people who are monitoring what that car's doing on the track, but also how it can be improved in between races. So just to talk about some of the, on a broader level, some of the challenges that we face in the 21st century, which I was talking about at the beginning, and I'm not going to go into huge amounts of detail about the climate emergency, but we all know that the world is facing significant challenges around this, and we all have to find a way of reducing the amount of carbon we produce, and we are all being put under pressure from a range of new legislation that's going to force us to reduce carbon production across many activities that we do. So that's a challenge for all of us. And then obviously we also, as well as carbon, as you use carbon, which sits alongside it, is the actual cost of energy. And I don't think we can tell anybody, and this is globally, about how all living costs are going up, particularly driven by energy. And this was a snapshot of the wholesale energy prices, hot off the press. And the reason I know that is because our headquarters building, we've been looking at energy costs, and we were flabbergasted to see that the daily average cost is 38 pence a kilowatt. And just to give you an example of the impact that has, so this is Spaceworks, which is our headquarters, 30,000 square foot commercial office building. But when we were planning for 2022, so 2021, our output energy costs were £45,000. And in 2022, we are projecting that that will be increased to £120,000. We're doing nothing different. That's a 165% increase. So that is pure money off the bottom line. And actually, we only have one building, and it's not a huge building. So you can see the potential impact that's going to have on business. So what is the value of a digital twin? A lot of hype, a lot of excitement around the technology, but what can a digital twin actually do? So we've identified 4 main areas that we think a digital twin can offer value. And over the last few weeks and months, we've been doing individual webinars about each one. So operational performance is the one that probably people are more familiar with, and that's looking at how we can reduce waste and look at cost savings on how the building actually operates, whether that be facilities management. Then also it provides increased sustainability and resilience by reducing the greenhouse gas emissions from a building. And what we're talking about today is productivity, and that's around how we can understand human comfort and impact on that impact on healthy environments, and then outcomes for business. And then finally, we can understand how we use the spaces with improved space utilization. So those 4 areas are the areas that we believe are the priority areas of value for a digital twin when it comes to buildings. And when over the years ahead, where the real value will come when we bring those 4 areas together, and we learn and we gather data, and we can use machine learning, artificial intelligence to bring that together and learn how we can improve our buildings in the years ahead to optimize them. Then just touching on some digital transformation and how the world has been evolving at a great pace. So back in the 1980s, that was the highest tech car there was on the left-hand side. Lots of buttons, but not particularly sophisticated. On the right-hand side is a new electric Mini, that happens to be what I drive. And certainly, I've never been under the bonnet. It's electric. It's more like driving a computer than it is driving a car. And you can just about drive it without needing to do anything to you need to do is turn corners just about. So the progress there into digital is significant. And then the other similar kind of progress is around simple level thermostats. Back in the 80s, you turned your thermostat up or down, and you used the degrees, it would probably be Fahrenheit in those days. But now we have things like the Nest, which are, they have built-in artificial intelligence, which are constantly learning about how you use your house and how it can optimize the energy that you use. And then going into buildings themselves, buildings have become increasingly sophisticated, where it was lots of big pipes and valves, the incredibly high-tech buildings now with very sophisticated systems built into them. So that asks the question, what do we actually know about our buildings if they are increasingly sophisticated? Well, the truth is they're fairly, in a lot of cases, buildings are fairly dumb. They are big lumps of concrete and we don't know very much about how they operate. However, what we do know is there's some very, very sophisticated systems in our buildings and they are being implemented but not used. So many buildings, if you go down at the basement, typically you will see there's some very sophisticated building management system, but rarely touched. Maybe an engineer might go down there once a year to have a look and maybe pop down if there's any particular issues, but really very underutilized, and none of that data is saved, recorded or used that's coming out of those buildings. But at a similar time, if you look what's happening in other sectors, and this is what I would class as catwalk, but if we take where buildings are very much at the beginning of their journeys, the art of the possible can be demonstrated by Formula One and how they use data to create the perfect racing car. I put Mercedes up here because anybody who does watch Formula One will know this car has had some real struggles in that whatever data they're getting is giving them problems with flexibility and affecting race performance. So they are looking at all of the data all the time. Then if you look at the kind of work that goes into, there's two cars on the track, the number of people on the left hand side is the aerodynamics office for Mercedes, and I think there's 160 people I was reading that are in there just to get the aerodynamics and how digital technologies are used to optimize that. And then this is an interesting one. On the left hand side, that is the control room or the data room for race day, which is back at headquarters. So here they're analyzing lots of data about the track. And on the right hand side, you've got the control that's going on at the track itself. So you can see that all of that technology about bringing data, using it to optimize the differences making for Formula One. The interesting thing, the majority of that technology that's in there now connecting to sensors, it's all possible, and in the built environment and in many buildings it exists, it's just not used or used for analysis. So the reality is how we operate our buildings is we have many files with lots of information in, and that's probably about as much as we know about our buildings. That's the big handover that comes at the end of a project, and then within the first week someone's pulled a file out, taken the drawings out of date, and actually can be quite dangerous. So buildings are very analog at the moment and very labor intensive to keep those up to date is quite a task at a time when the technology exists similar to what they're doing in Formula One and aerospace. So then just another section just to look at how this, what this looks like in relation to real numbers of operating a building. And every time I've looked at this and shared this information with us, there's a real surprise. So we've done a bit of research into what buildings actually cost to run. So we used a building example, sorry, but we used a building example in London just because we knew some buildings there that we were familiar with. And we've gone for a 10,000 square metre office building in the West End of London because we had stats for that. So it's not a huge building, but it is, to be fair, in a very expensive part of the world, probably one of the most expensive parts of the world to own a building. But the average operational cost of running a building like this is £175 per square metre. And of that, £41 is repairs and maintenance. So on a building like that, you're talking 1.75 million just on maintenance and operational costs. And that's not including energy. So then we'll move on to the energy costs. The average kilowatt used in an office building is 234 kilowatts per metre squared. The target for to achieve EPC-B, which is what the government are going through a consultation at the moment on, is to get buildings down to 55 kilowatts per metre squared. So you can see that's a huge impact on what we're trying to achieve. Our head office, we've spent a lot of time, money analysing the building and used passive means. And after a lot of time and effort, we've got ours down to 110 kilowatts, which is impressive. And I must admit, I'm not sure how we can get any lower. So I think 55 is a real challenge. But we need to understand if that's the case, where all the energy is being used. So when you take all of that, building a 10,000 square metre building is about 2.3 million kilowatts, which equates to 723 tonnes of carbon. But importantly, the actual energy cost, based on a electricity cost of just over 30 pence, is 772,000. That's a huge amount of money, and has probably more than doubled in the last 24 months. And there's also potential that it could go any further, go even more. And then talk about productivity, which we're going to give a little bit more in-depth look. Just the amount of time that is used, wasted in office environments, around people days, just from sickness, could be anxiety, could be other illnesses, even COVID and the challenges such as that. So the environment is very important. And then how we use the space. So as I mentioned at the beginning, offices are not being used as they were pre-pandemic. So there's lots of spaces being underutilised. And when you're paying £1,000 per square metre in the West End of London, every metre counts. So if you look at the cost of that, you're talking £10 million to rent a building in the West End of Newcastle, West End of London, and the rates that go with that is 5.5 million. So you have to analyse every single square metre, and when they're sitting empty, it's costing building owners and companies a lot of money. So when you top all that up, you're looking at £20 million to run a 10,000 square metre building, a huge amount of cost. So you just, even if you looked at some marginal changes, you could save £1 million with only 5% of slight adjustment. So the impacts are significant. So if we look at productivity itself in a little bit more detail, and I think what the biggest thing that's relevant around all of this in digital twins and buildings, we know very little about our buildings, how they perform. We aren't gathering data, and a lot of that's been because the thoughts are, well, the energy cost will be what it is, and actually there's not a great deal I can do about it, and it's not that significant. When energy costs are going or more than doubling, I think it's business critical, in that it's a bottom line issue. If you've got a energy intensive building which has a swimming pool in it, or even if you're a gym with saunas and things like that, or a hotel, your energy costs will be huge, and you'll be getting absolutely increasing costs week on week. So as Peter Drucker said, if you can't measure it, you can't manage it. So we need to know more about our buildings. We need to know what our people are doing, and we have got a good understanding of what they're doing, but we don't know enough actually how they're doing it. How are they spending their time? And particularly now when people are working from home, what's the difference in the efficiency of working in the office? How can we maximize that? And then how is that work optimizing, impacting on outcomes. So for that, we need to know more about our environment, and there's lots of research around the impact the environment has on our well-being. And well-being is very important to the current workforce. So Generation Z and Millennials put their well-being very high up their agenda in a world where we're in a talent crisis. How people feel in the work environment is very, very important. So what a digital twin can help with is understanding air quality. And the surprise to me was that air quality within an office building is 3 times worse than the air quality outside. And we've been monitoring air quality within our offices and watching how people's uses of that space makes a difference on that air quality, and what different times of day, what different times of year. So understanding that better, the levels of CO2, oxygen, and the impact on outcomes. So as long as we're keeping fresh air going in, we're seeing that helps people certainly in later parts of the day. Lighting levels is an interesting one. Different people have different preferences on the levels of lighting. So we've been monitoring that, different lux levels, different parts of the building. Can we drop it down? It doesn't have to be consistent necessarily. And what impact does that have on people's feeling within the office? And then the one that everyone knows about is the sensitivity around temperature, how some people like their workspace to be warm. Some people would prefer it to be cold. In open plan offices, obviously that's a challenge. There's obviously also the cost implications of that. And some recent research said half of employees are less productive when they're cold, and a similar kind of requirement in relation to people's expectations of improved air quality. So I think what this is saying is that people are understanding their environment more, and it is increasingly important to their place of work and how they work. The other area which a digital twin has been helping with is actually how the space is used. So very easy with sensors, you can do some spatial analysis, and we've been doing that with Twinview on a number of buildings, and it's proved to be quite interesting. I think one of the things is you can track the spaces that are being used. So we've seen some spaces that are more popular than others, and generally that's around where the best quality of light is, but not necessarily always, because sometimes there's overheating. So we've been able to monitor that. And then we can see how space is being used. And as I mentioned, some spaces aren't being used. So certainly in our own office, we're seeing large parts of the office are not used throughout the week, because we've got hybrid working policy. So it's sort of impacting on business decisions, especially when utility costs are so high. And then that's one thing for how a building operates. But we think from a design optimization point of view, when we come and design future buildings, we would know more about them. We would build in more flexibility. I think a lot of it's around how you meter and how you can monitor spaces. So it has what we learn about our buildings will have a huge impact, not just on existing buildings in operation, but also how we deliver buildings in the future. The other side of a digital twin, I've talked very much around the physical building side, but obviously the building's full of people, and we need to know more about those people. We need to understand how they interact with the building itself. And there are many user experience apps out there. Twinview has a slightly different approach in that we connect our user experience app into the building digital twin. So we've got a human-centric twin and a building twin, and where the real value is when we bring those two elements together. And it's important that we use that to connect people with the environment that they're in, and we can understand how they're using it. So it allows people to interact. They can interact with each other, but they can find out more about activities around their well-being. And then also gives them access to information. I was reading some interesting research around how wellness is impacted on people's access and ease of finding things, frustration, some interesting things around that. And then also nutrition, how we can monitor what people are are eating more of at the cafe than other things, not necessarily at an individual level. And one thing, a caveat of all of this is anonymized data. But what it's doing is demonstrating how your building is used, what times it's used, which teams are using space more than others, what is the preference temperature. So for example, if one team likes the temperature at 20 degrees, you can reduce the preheating. If you know a space isn't going to be heated, it isn't going to be used on certain days by certain teams, you don't have to preheat to 22 degrees, for example. You could just preheat to 18. So all of those things, understanding how it's used, will impact on cost, but also improve the productivity of the people in the space. So what this is all saying is that there is an opportunity for us to use buildings in a very different way, and use the data that are on buildings differently. So at the moment, information from buildings is siloed. It's in lots of different places. So building owners do have access to some information. So they may have that operational maintenance information, they may know their operational costs, energy costs through invoicing, but they might have drawings in different places. The model that they've got, they might know the help desk is operated by somebody else. And there's other things they know nothing about. So they might not know about user comfort, they don't know the impact the catering's having. So buildings have huge amounts of data and information, but it is in lots of different places and not connected, and therefore not used intelligently. And it's not therefore informing decisions on a broader spectrum. So platforms, digital twins, what they do is they bring all of that information together. So what Twinview does is brings all of that information into a single database area. Doesn't have to necessarily all be the Twinview platform. We can bring in data through APIs from other platforms. But what it's doing is, importantly, centralizing that information. And then that gives us, using a portfolio dashboard, we can get access to all of the information and view it all in one place alongside all the different data. And then, as I've touched on a few times, we can use that data when it's all connected together to learn and then simulate and predict how the building's going to operate. And then therefore, from a productivity point of view, you can really start to understand the impact of an environment on that productivity and changes that we can make to improve productivity. So then so what it's doing is providing, this is just an example dashboard that we have. So we have a number of set of dashboards in Twinview, and you can customize them wherever you want. But this is providing information for digital twin, is providing this information collected from lots of different places and pushing it into a single place, so you can start to see what you're actually spending. And I think one of the certainly in our head office, we've been using Twinview for some time now, actually seeing your energy cost, what you're using, what impacts on it can be quite sobering. And it's a bit like, for those of us that have got energy monitor devices at home, when you see that the energy that a fridge is using, or if the tumble dryer goes on, it does change behaviours. And I think it's the same with buildings now, when people are actually realising that buildings are energy costs are increasing hugely and having massive impacts on business performance. So yeah, Twinview grabs lots of that data and gives you huge amounts of data on a whole lots of different dashboards. And we've found that when we're looking at buildings, we've seen certain patterns, behaviours, how people use buildings, certain floors that we've seen are being heated to 21, 22 degrees and then only have 5% occupancy throughout the week. So you can start to pull that data. We've seen some areas where individual users have had temperatures really high, up at 24 degrees, and there's only been limited use. So looking at productivity, are those people more productive at those levels? And if they are, can we heat smaller areas? And it's all information that needs to be analysed. So really to wrap up, if we understand these four main areas and have more data about it, the potential in buildings is where we bring all that together, use the artificial intelligence to improve all the outcomes from a building and ultimately improve productivity across the board for business. Okay, so that's 40 minutes, so that is about on time. So I'm happy to have any questions if you want to put them in the chat. It'd be nice to get feedback or thoughts from people. You can put it in the Q&A or the chat. I'm happy to answer any of those questions. So the first question that's coming: how does the tenant app connect building occupiers' issues, concerns to building managers? This is one of the important things around productivity, is that the ease of connecting through a mobile app that's sort of on your desk and on your phone, that if you've got problems, so there is evidence that shows that if people are frustrated in their environment, or the temperature doesn't work, and how long things take to be repaired. The good thing about having a mobile application of these sort of things, you can contact help desks really quickly, then you can track that. But also, in some cases, you've got control of temperatures yourself and light levels. So some of these things you can even address yourself. Yeah, good question. What challenges have you experienced and overcome relating to interfacing with data sources from third-party building systems, building network protocols, etc.? Twinview is built for exactly that. We're not saying to anybody that you must use Twinview. What the purpose of Twinview is about a way of bringing all the data together. So Twinview is built on an API, and provided the data that we're interconnecting with has an API, our experience has been that we can connect very easily. Twinview has its own built-in endpoints. You can actually do it yourself. You only have to have a limited amount of knowledge. So we've connected in with lots of different platforms, facilities management platforms, asset management platforms. And what that's doing is, so some information is coming direct through Twinview, but also are taking data off the BMS or the facilities management and putting it all in the same place onto a single dashboard, which can be configured. And generally, one of the surprises, we've been in this field for 3 or 4 years now implementing, and our big surprise when we did this was the investment that's gone into building management systems and where the data isn't used. So the information isn't used, it's sitting there. So we found with some very easy, quick wins where we were able just to connect to existing BMS systems. And the big difference with Twinview is we're storing the data to be used in the future. A lot of building management systems are not storing it or recording it for any significant amount of time. Okay, if there's no other questions, I'll let you get back to the office, make sure that productivity remains high, because you never know, the sensors could be watching. So thank you for your time. I've enjoyed researching the subject, which has been good, and hopefully you've picked something up today. If you've got any further questions, I'm more than happy to continue the discussion. As you probably picked up, it's an area of particular passion and interest for me. So thank you very much for your time.